This is the independent practice for 8.1. Hopefully you've had a chance to do it, and now you're just checking, see how you did. So we have input, function, output. The input is right here. Here's the function, and here's the output. So this equals x, this equals x, this equals x. So if our function is 3, then I'm going to do parentheses like this, 0 plus 5, and I'll see what my input is. I times 3 times 0 together, 0 plus 5, add those together, my output is 5. Okay. Now I'm going to do the same, 3 times 3 plus 5. I put the parentheses here as a way of just saying it's 3 times 3. And when I do 3 times 3, it's 9, plus 5 gets me 14. Okay, 3, I could go a little dot here, times 9 plus 5. And that would get me 27 plus 5. 27 plus 5 is 32. Okay, so I got all my inputs, got my outputs, here's my functions. Let's go over to the next one. Number 2. Same type of thing, output, input. And one thing I would remind you, especially for later, the output is y. The input is x, and the output is y. So, I got to get an output. 4 coming in. So 4 is x, x minus 4. What's coming out is 0. 8 goes in, 8 is my x. 8 minus 4, that equals 4. And then 11 minus 4 equals 7. So I have my inputs and then my outputs. Okay, number 3. Number 3, I have the output, I have the function, I just don't know what goes in. So, I could guess a little bit here. If I guess x is 0, I'm going to put 0 plus 2 equals 2. Okay? So if my input is 0, my output will be 2. Now, what if it's 1? 1 is x plus 2, that does equal 3. Now, basically what this is saying it's x plus 2 equals my output. My output is 8. And I just got to figure out what x is. So if I want x all by itself, I take 2 away here, take 2 away here. X equals 6. Okay? So I think x is 6. 6 plus 2, that does equal 8. Okay? So there's a way to find it using the algebra that we were just using last chapter. Let's go over to 4. Another one where we have the output, but not the input. A much trickier function here. So, this is going to be 2x plus 4 equals my output of 18. And the way I find that is I'm going to get rid of this 4 on this side, get rid of 4 on each side, then it leaves me with 2x equals 14. Now I want to get the x all by itself, so I got to divide this by 2, divide that by 2, and x equals 7. So I think my input is 7. I'm going to erase this, and now I'm going to put 7 in there. 2 times 7 plus 4. 2 times 7 is 14. 14 plus 4 is 18. Okay? The next one is 22. 2x plus 4 equals 22. Get rid of the 4, get rid of the 4. So it's 2x equals 18 divided by 2, divided by 2. x equals 9. Let's see, 9 goes here. 2 times 9 plus 4. 2 times 9 is 18, plus 4 does equal that 22. Perfect. Alright, last one in this function. 2x plus 4 equals an output of 34. Okay, so let's get rid of this 4. 2x equals 30. Then divide each side by 2. X equals 15. So I think it's 15, but of course I want to check. So let's check it. 2 times 15 plus 4. 2 times 15 is 30, plus 4. 30 plus 4 equals 34. Okay. Let's see here. We have a word problem, but we have our function here. We have our input, our function, our output, and then we have a graph here. The x is on the bottom, the y is over here. So this right here, number of guests, that's my x or my input, and then my output is over here on the y. So let's see. Whitney has a total of 30 cupcakes for her guests. The function rule 30 divided by x, so there's my function rule, is where x is the number of guests, can be used to find the number of cupcakes per guest. Make a table of values that shows the number of cupcakes each guest will get if there are 6, 10, or 15 guests. Then graph the function. Okay, let's do 6 first. 30 divided by 6, that gets me 5. All right. 30 divided by 10, that gets me 3. 30 divided by 15 gets me 2. All right. So if you want a lot of cupcakes, you want to have a smaller number of guests, because if there's only 6 guests, each guest gets 5 cupcakes. But if there's 15, each guest gets 2 cupcakes. So let's start with the x and the y. So 6 would be right about here, right between those two. And we got to go up to 5. So 6. That's the first one. Then we go all the way over to 10, which is right here. And then 10 goes to 3. So right here. And then 15 would be like right here, and that goes up to 2. Right here. Okay. So we got our line right there. All right. That was filling in the chart and graphing it. Let's do number 6. Bella rollerblades 8 miles in an hour. The function rule that represents this situation is 8x, where x is the number of hours. Okay, so there's the number of hours. We do 8, and then we find out how many miles. Make a table to find out how many hours she has skated when she has traveled. Okay, that's my output. 16 miles, 24 miles, and 32 miles. Okay, so to figure this out, 8x equals 16. I want to get the x by itself, so I divide each side by 8. X equals 2. Let's give it a... Ooh, whoopsie. Let's give that a try. 24, 32. What did I think it was? 2? I thought for 2 hours. So then, 8 times 2 equals 16. Yep, perfect. Okay, I'm going to do 3 here. 8 times 3 equals 24, and 4, because I know 8 times 4 equals 32. So for 2 hours, here's my 2 hours right here. I'm going to go 16 miles. So 2 hours, 16 miles right there. 3 hours goes 24, so there's 3 hours. 24 is right about here. And then 4 is 32. There's 4. 32 is all the way here. And then I have the line like that. Okay? So there I made the chart, made the function table, and then I graphed it. Now, number 7. Refer to exercise 6, which is what we just did right here. How many miles would Bella travel if she skated for 7 hours? So 7 hours right here. The function is 8 times x, which is 7. 8 times 7 is 56. She would skate for 56 miles. Alright. Hopefully you did okay. If you have any questions, let me know.